Hi guys, and welcome to the next part of the Skyrim tutorial series. Today I will show you how to create a complete Bone-ESP from the beginning to the end. And we will start by searching for our local players' bones in memory. Then we will add most of the bones to a new class which we will create and start drawing all of them as numbers to the screen. And at this point it will be kind of easy for us to identify which bones we want to draw at all, and we can connect them to each other accordingly. First I will present you an address which we will use to access our local player's coordinates in memory. So if you open this address in the disassembler, you will end up here, and if you have a look, find out what addresses this instruction accesses, set this to float and go back in game. Just one address pops up, and this is our Z coordinate. In this case we will just use this one to access the local player base, and we have to subtract 3C in this case from this address, so we get the base. And we will open our trusted ReClass again, and attach the game, of course. We will edit this one. Have a quick look. Yeah, that works. Awesome. Okay, so how do we find the bone structure? This is our Z coordinate, and when I was first searching for it, I thought to myself, how can I find the head position? So what I'm going to do now is I assume that, or basically I know that this is the foot position, because we already drawn the menu, the ESP, and the head will probably be around, let's see, 450 up to 550 probably. And let's just search for these values up to 550, or let's say, I don't know, 600. Let's do a quick scan. Now let's crouch for a second, search for decreased, increased, decrease, increased, because we are searching for the head coordinate, or probably the shoulder coordinate, or at least any coordinate which is not at our bottom, and which is probably in the upper part of the body. So we will crouch again, increased, decreased, increased, decreased, increased, decreased, increased, decreased, increased. And what I want you to notice is that the body is moving, so we are not standing completely still. So what we're going to do now is decreased, increased. Now we wait a second or two, and we will search for an changed value now, because we are slightly moving, and these values you see on the right, which doesn't move, I don't know, are probably related to a hitbox or something, but they aren't moving. And when I hit changed value, like you can see, we end up with 129 addresses. You can clearly see that these numbers are somehow connected to my character. They are increasing and decreasing as I move, or as I crouch. And what I basically did was I was looking at tons of them in the memory regions, and I was just looking for a sequence or something that looks like some kind of bone structure coordinates. And this, for example, looks promising. We have the that coordinates over here, and probably this one also. We will just open this one in ReClass, which I also did a lot of times, and let's have a look what we got here. Tree shape. nothing too interesting. So if we continue with this one, or let's have a look in the memory region first, it makes sense. Here also a lot of Z coordinates. And if we have a look over here, oh, we are getting closer. Like you can see, ReClass is such a nice guy, or it's a girl, I don't know, and is delivering us directly the name from the bone. So we got the twists here, but we see we are probably not directly at the right place because we also have a pauldron here and the weapon stuff and the quiver and some other stuff in here, but you can directly see we are at 1A755 and these are all connected, and that's why I will open the first one in this case, because we want to get at the beginning of the bone structure. And let's have a look at this one. Okay, so we have written over here NPC, we have the pelvis, the tight calf, foot, toe. This looks good so far, but we still don't know if this is the beginning. So what we are going to do is we just decrease the address a little bit. Let's replace the E to an A, for example. And then you can see here is nothing. And if we scroll down, this is the first part from some kind of bone structure. But we don't know yet if the structure begins here, or directly here, or maybe here. So to identify this one, what I did, I grabbed the coordinates from the first bone I found. So when this is the first bone, this is the Z coordinate, as you can see. And these are probably the vector 3 related to this bone. And if we scroll down, you see this is some kind of rotation matrix. And here comes the next vector 3. So what I did in this case, I grabbed the address from the first X, from the first bone, copy this one, add this one to our trusted list. Let's call this pelvis X, and it's a float. And the problem we have right now is we have this structure and we know it is connected to our local player, but we don't know where it is exactly in the pointer structure. So it can be directly on the first pointer we access on the local player base. It can be 5 pointers deep. This is what we have to find. So what we're going to do is a pointer scan in range from our local player, which will result in fewer pointer structures, and we can identify kind of quick where we have to go. We will add a specific range. The beginning in this case is obviously the beginning of our local player struct, and we will just add the 1000 to it. And you have to really experiment with a max level. It depends from game to game. I suggest starting with 4 or 5 is a good range. And if you get too many results, you can decrease, but it will still take a lot of time because you have to manually validate the pointer structures you get as result and see if they can survive restarts or even PC machine restarts. And yeah, this is something which takes a lot of time. So let's go with a 4 in this case. Let's start this one. Okay, here we are. The pointer scan is finished. We have 25 results. we directly see 2 of them are in a max 3 pointer range, and the rest is in here. If you never worked with pointer scans and ReClass together in this case, this one is the base address, but you have to calculate the starting offset. So what you can do is sort by base address and then make a double click on here, grab the base, it's this one, and you have to subtract from this number, you have to subtract the local player base. So you know it's offset 44 from here. So the beginning would be 44, this pointer, and from there 318 and so on and so on. But you also have to test later on if these are really structures you can use after a restart, so you have to validate them. In order to save time, I can tell you that this is the correct one. And yeah, let's build the ReClass structure and the Bone class. Okay, so let's grab this one. Let's get the base address. And let's subtract our local player base from it. And you see we start at offset 188 in this case, which is this one. This is a pointer. Let's call this Bone pointer 1. This is Bone pointer 1 class. You can rename them, of course, it's just for the sake of it. Then we got 4 CO and DO. So this one would be here. We call this one and when we expand this, you can directly see we are inside a flattened bone tree right now, but it's not that class we were looking at. So we have to go also in the CO. Where is it? Over here. This is our last pointer. This will be Bone pointer 3 and Bone pointer 3 class. And if we expand this one, you see we are directly where we were looking at before. We are at the beginning of the pointer structure. Well, unfortunately, Skyrim have tons and tons and tons of different skeletons in the game, and they will be named all differently. They have a different amount of bones in there. And what we need to do is we need a way to validate that the object or the bone we are about to draw is related to a humanoid skeleton. Otherwise, we will draw shit. So what I learned during trial and error is that we can use this one as a validation. We changed this one to a pchar, and we call this humanoid validation. I just typed this before. And NPC com is only written when we are dealing with a humanoid skeleton. So sometimes there is also chicken or horse or something else written in there, and we'll later use this one to validate. What I'm going to do now is I will declare every vector 3 from every bone, or from a lot of bones in there, and I will just speed up the video so we don't lose a lot of time. And because we will first draw all of the bones to identify which one we really need, I will just name them B1 till B40 or something. Let's see how many of those we got. And you can rename them later on if you will really want to. Okay, well, I ended up with 48 bones, and which we will add to the bone class, and I'm very sure we just need a few of them, but first let's draw them all and see what we need and what we can trash. So that's it for the first part, and in the next part we will draw all of the bones. We will identify which ones we need for the skeleton, and then we will draw these ones and connect the bones to each other. Hello and thank you so much for joining me. Today we will write a Bone-ESP and display the humanoid skeleton on the screen. So the first thing you want to do is moving all three bone classes from ReClass to Visual Studio, and you also want to update your local player class because it now contains the pointer to bone class part 1, which leads to the second class, which leads to the class which contains all 48 bones. So what we are going to do now is drawing all 48 bones to the screen for every humanoid skeleton. We do this by using a function which I already have in the DirectX CPP. It's called drawNumber. So this function is taking a vector 3 and a character from you and is running a world to screen and displaying the string at the returning x and y. After that we will identify which bones we want to draw in all and how to connect them to each other, which we will do with a different functions called drawBone, which takes two vector 3 from you and is connecting the bones to each other. I'm sure there are probably other ways to draw a Bone-ESP. If you think you can do it better, please post a solution in forums so other people can learn from it and can do it better in the future. But the way I'm doing this now is working very well for me, and that's what I'm presenting you today. Okay, let's declare a new menu option real quick. Let's call this Bone-ESP, set the number to 6. Then if you scroll down, as always, you have to create a new if statement. Bone-ESP, this is 5 now, and Bone-ESP, which doesn't exist yet, is true, and in here it is false. So we're going to create a new bool real quick, call this Bone-ESP, it's initialize false, and now we are just copy the normal name ESP in this case, just paste it in here, call it Bone-ESP. By the way, I made a typo in the height int in the part 2, so you probably noticed this already. If not, fix this please. It doesn't make a big difference. So this can stay the same in this case, and declare new 2 strings over here please. The first one is called isValid, and the second one is called validation name, and this one is what was written in the ReClass, in the Bone class, when you remember, where I said we can use it to identify if the entity is a humanoid skeleton or not. And in there it was written npc com, and in here com again, and it looks like this. Okay, so the world to screen can go, everything in here can go, and is valid will be ends bone pointer 1, 2, 3, and it will be the humanoid validation. So we will get this string from every entity which is accessing our if statement, and then we can validate if the entity is an actual humanoid skeleton, in this case, by comparing it to this string. So all we have to do is changing this one in here is valid is the same as the validation name in this case, and this will do the job. Only if this is the case, we will access this if statement where we draw the numbers in this case. So we say draw number, then we pick our current entity, bone pointer 1, 2, 3, and we pick the first bone. Now we need a char in this case. Let's just say 1. We will be using our predefined matrix, and the color I pick red in this case, and 0, 0. That's it. And this is what I'm going to do now for every bone. I will speed up this a little bit. You can do this yourself, and then we want to see how it looks like in game. Okay, so I have all 48 bones in here. I just compiled and injected, and now we will have a look at all the bones and see which ones we actually need and how we connect them to each other. So let's switch to the game and let's turn on the Bone-ESP. This looks like this so far, and we start at the top, and you can probably directly see 27 is the chin, 28 is somewhere between the eyes. And I would say we will start at 26 and connect this one to 25, which is the middle or the lower throat or the neck, it seems. Yeah, directly in the middle. So we switch to the old school Notepad 1, where I don't have 1,000 things opened. Okay, so head is 26 and we want to connect it to 25. And if we have a look at 25, from there I would say we connect 29 and 39 is a little bit too far at the front. I would say we connect 25 to 30 and 40. So if we say we start at the right arm, we can connect 25, or let's say 25 to 30 and 25 to 40, and the right arm will be 40 to 47, 40 to 47 to 41 to 45. 1 and 41 to 45, 44, 42. Okay, to 44 and 44 to 42, and the same in this case for the left arm. As you can see, it's a direct opposite, so we just copy this one, and all we have to do is change the 4 to the 3. So this 30. I will recheck this in a second, but I'm quite sure this is going to be true. 25. This is correct. Yeah, okay, so this is good. And now for the back. So from 25 we will connect to 24, to 23, 22. Let's have a look. 25 to 24. Oops. 25 to 24. So to 22. We are down in here right now. And from 22, I would say we go 22 goes to 6 and 2. So we have each leg. So back or lower, 22 goes to 6 and 22 goes to 2. And then we have the right leg and the left leg. The right one would be from 2, 3, 4, 5. And 4 to 5. 2, 3, 4, 5. And the left leg is from 6, 7, 8, 9. And we connected 22 to 6 already. So 6, 7, 7, 8, and 8 to 9. And I think this should be it so far. So I would say let's ditch the draw numbers and let's connect these bones to each other. Okay, so I'm going to leave the game in here. We can comment out all of these for now. And let's say draw bone, the current end, pointer 2, pointer 3. This is connecting two bones with each other. So we will start in this case with at the top probably, let's say 26 to 25, 20 B26, and let's copy this one. It will go a little bit faster. So this will be connected to 25. Then we need our matrix, of course, again, and let's get red already. This looks good. We will just call this head. Let's connect these two, 25 to 30. And 25 to 40. 25 to 40. And I will speed up this part for you a little bit so you don't have to wait so long. Okay, all of the bones we need are connected now, and let's have a look how this looks like in-game. Let's inject real quick. Inject. And if we enable the Bone-ESP, right now it's drawing, of course, on ourselves also. You can fix this, but you can see it looks pretty good. You can, of course, expand this one and add a head dot, or if you want to go the creepy road, you can also add fingers to the skeleton. And yeah, that's it so far. I hope you had fun and can use this technique for some other games. Have a good day.